So you can find that schedule over in our website. And yeah. Alright, it's 12:30 now. Alright. Okay. Alright. So. Hello, hello, welcome, Chuckley. How's it going? Good? You want another granola bar? You want for the day?
Yeah.
Yeah. Alright. You too, Sensei, you want one?
Sure.
Yeah.
Thank you.
Of course. There we go. Feel free to take more. Alright. So, we'll go ahead and get started now with the lecture. Welcome everyone. Welcome back to CSE 8A. Today we're going to be covering something called conditionals. Okay? Yesterday's lecture was all about functions, about using code that you want to reuse over and over and over again, right? Things that you could just keep on calling. And that was like a big key, a really big key theme of what computer science really is. Like something that you're going to be using a lot in your computing career, right? Whether it's just this course or if you want to take various courses after the fact, right? Functions are going to be very important. Another thing that's very important is conditionals. Okay, there's another very important thing, another important aspect of computer science that we'll be covering today. But again, as always, we're not going to just dive into the deep end, right? We're going to slowly get to what we need to know for conditionals. Okay. All right. Before we get started, why is it important to have diversity in tech? This is something that is very important to me, right? Trying to create a more diverse computer science population, right? And whenever I can. And this is just like one example of what it could be. There's this thing called the racist soap dispensers. You know those automatic soap dispensers? You go put your hand and you get something and you wash your hands, right? Same thing with like, gel antibacterial. How do you say it? Germex. It's like when you're trying to get Germex as well. Basically, some sort of sensor that can read that there's a hand there. So you can put your hand and it'll give you soap, it'll give you Germex, it'll give you whatever you need, and you can wash your hands, right? Turns out that when they created these soap dispensers, sometimes it would not respond to darker toned skin, okay? And that's because, well, unfortunately, because the people that created the soap dispenser were probably not really a diverse team, didn't really think outside the box of who's going to be using these systems, probably only tested the system with likely lighter skin toned hands, right? And because of that, whenever they go and test it, if they had lighter skin toned hands, it would work. And they said, oh, this is always working, therefore, this system is good to go, right? However, because they never thought about darker skin toned people, now anytime someone that wanted to go and get some soap and they had a darker skin tone, then it really wouldn't work for them, right? So this is like one small key aspect of why having diversity in tech is really important, okay? And I can talk about this for literally a whole course, but of course we're not going to be talking about that for the whole course. It's just something that I wanted to bring up to you all about how technology and society do interact with each other at all times, right? We can't just be creating our systems without thinking about who's going to be using them. Why is it important that the people that we're creating things for, to make sure that we're more open-minded about what type of stuff we're making, right? And who's in the room when we're building these things. Anyways, some quick announcements. PA1 will be due on Monday. I highly recommend you all get started on those programming assignments as soon as possible. So if you have any questions whatsoever, you go to office hours, you go to tutor hours, or you can ask Code Help, the Code Help system, for any help that you may need to finish your programming assignment, which is due on Monday. Again, you do get slip days. You could use some slip days. I wouldn't use it for PA1. I would personally use it for probably PA5 and 6, but we don't have to worry about that just yet. So again, if you have some things going on, of course, use your slip days. Now, and also, Lab 2 is today. Remember that we merged our sections together, right? Our section and the section with Anshul Shah, who is the other instructor for the other section of CC8A. So again, the time of day is going to be the same for lectures, for labs, and for discussions. It's just that we switched the days of when we're meeting and the location. And all that information has been sent out to your emails. So yeah, today is lab 2. Today is going to be in the CSE basement. I think it's going to be 250, B250, 250 or 260, B260. Okay, basically wherever we met before for the other lab, it's going to be right next door. It's not too far away. And of course, it's really important to practice. Make sure to practice your coding skills. Whenever we have some sort of exercises, make sure to try and actually do it on your computer, right? Make sure to do it on your computer and try to figure it out before asking for help. Really try, and if you don't make it, that's okay too, right? If you could write everything that we give to you on your first try, then maybe you're not even supposed to be in this class, you're just supposed to be in the next class, right? So it's okay to try something and it doesn't work out, that's totally fine, but it is really important to practice. Practice your coding, right? So, again, we have this participation form. It is on the slides that are already linked on the schedule, which is found on the website. So you can start using it to go and answer some of the questions that we'll have coming up. But we can go ahead and get started with those questions as we go along with them. You don't need to use the participation form, but it's totally fine. All right, so our last class, as I said before, we were looking at functions, using built-in functions that already exist within Python, such as print, such as input, right? We also wrote our own functions, right? Defining a function, defining with the DEF, right? Defining a function. Also calling a function, making sure that you call its name. And also making sure that a function, it's asking for something. I forgot to mention this in the last class, but the thing that we give to the function, that's called a parameter, okay? Parameter, that's the keyword, parameter. The parameter is basically what the function is asking for, right? And then we also looked at the control flow of functions, right? Making sure that where we're calling this function actually depends on, where we're calling the function is important. And then also the difference between printing something and returning something. Can someone remind me what's the difference between printing something and returning something?
Returning it allows it to be stored in a variable, and printing it just puts it in the terminal.
Yes. So basically, printing is something that you put into the console, into the terminal, right? It just says something out loud, right? You're not moving that data anywhere. You're not actually grabbing some sort of data and moving it somewhere. You're only saying it out loud into the console. Whereas returning something is whenever you have this data, you get to the end, you want to return something, give it back to the person, give it back to the user. You grab the data, right? It could be a string, like hello world, or it could be a number, anything that you want, really. You grab it, and you give it to the user so that you could store it into a variable and use it later. Yeah. So returning is grabbing something and giving it to someone else, whereas printing is just saying something out loud into the console. Does that make sense? Somewhat? Yeah. Question?
Oh no, it's just like,
yeah, kind of iffy on it?
yeah.
All right, we'll get into it right now too, because we have here's a quick exercise. All right, so we have a function right here. We wrote our own function called area of circle. Actually, I shouldn't have said that. I gave away the first answer, right? So using the function above, answer the following, okay? What's the name of the function that we have up here?
Area of circle.
Area of circle. It's right here, okay? Remember, when we tell Python, here is the name. We want the name to be area of circle. Great. What are the parameters to this function? What's the name of the parameter?
Radius.
Radius. Yes, radius. It's whatever is inside these parentheses, right? Could we only have one number in here? Could we only have one thing in here? Or could we have multiple things in there? Multiple. Yes. How do we make it multiple?
Commas.
Yes, commas. You just put something, a comma, something else, comma, something else. Right? Great. So now we have this return value. What's the data type of this return value? Remember, we talked a lot about data types, like strings, integers, floats, things like that.
Float.
An area. So this is a float. Why is it a float?
It's area. It's like a decimal.
Yes, exactly right. Area is going to have a decimal with it. Why do we know that for a fact? because one of the numbers that's going to be multiplied has a decimal with it. One of the numbers is a float. Therefore, after we do this multiplication, even if these two are integers, we'll end up with a float. Okay? Does that make sense? Yes? Great. So area is a float. Fantastic. So what's the meaning of def?
Initializing a function.
Initializing a function. We call it, yes, defining. But yeah, it's initializing. It's initializing a function. It's defining something. You're going to define a function for the Python system. And you're saying, hey, Python, I'm going to make something. I want to define something. All right, what do you want to call it? Area of a circle. Okay, cool. What do you want to get in it? Something called a radius. All right, cool. You put the colon. You put your spaces. Remember, these spaces are very important. And then you do whatever math or any sort of process that you want in there, whatever program you'd like. And then here we're returning something. We're returning an area. All right? So does that make sense so far? Great, great. Let's look at what it means to, actually this is going to be a great thing about returning versus printing right here. Okay? So here's a quick exercise. What is going to be printed when the following program is executed, or whenever we run the following program? I'm going to give you all a couple minutes to just read this over and then see your options. Okay? I'll give you all just a couple minutes. So, anyone have any guesses?
Would it be D?
D? Hola, Mohana?
Yeah.
Okay. Why would that be? Let's walk through it.
Oh, I was just saying because
Yeah.
you haven't called the function, right?
You haven't called the function? I did call the function, it's just
Okay.
right here. Okay?
Oh, yeah, I didn't see
Yeah,
it.
so it's right here.
Okay.
So yes, there's this print, right? This print of hola, whatever name. In this case, we're giving it the name Mohana. Okay? So, we do call it once, at least once.
Maybe A.
Maybe A? Why would that be?
You call the function at the name Mohana, so it would print out Hola Mohana, and then you try to print the message, but it doesn't return anything, so it's none.
Okay, okay. So this is, let's try it out. Let's try it out, and then also, let's go with it step by step to see what exactly it will be. Yeah? So, I'm going to have here, there we go, a little bit bigger. Can you all see that? Okay, cool. Let's do the following. Let me see if it'll copy and paste well over here. Looks like it did. All right, cool. All right, so we have our, let me make it even a bit bigger. So we have our function here. We're defining it, it's called greeting, and we want a name. Then we're going to print out the name, hola, name, whatever name we give it. Then we call it, and we store whatever we get from the function into a variable called message. And then we're going to print out whatever that variable message contains. Okay? Let's run it just to see what happens. Run. All right. Hola Mohana, and then none. It is A. Okay? So let's go with it step by step to see exactly why we get this answer. All right? And we're going to be very, very, very strict, just like Python is, to make sure exactly how Python got the answer that it did. Okay? So Python, as you know, will read a file and read it top to bottom just to read it. Okay? Just to see what's going on. First, it reads this. What's going to happen here when Python reads this?
Function's created.
A function is created. We are initializing a function, as Ankit said before. Yes, we are initializing something. We're creating, defining a function called greeting, right? And we're going to ask for a name. And Python says, okay, Has anything been printed onto the console so far? No, right? Nothing's been printed on the console so far. Next, Python reads this line, line 2. When Python reads this line, it says, okay, this is part of the function greeting, okay? I'm not going to do anything yet because we never called greeting yet, but I'm just learning right now what greeting does. And I know that greeting will print hola, and then whatever the name is that's given with an exclamation point. Has anything been posted onto the console just yet? No, nothing has been printed just yet, okay? Then Python reads this third line. What happens here? It's empty space, nothing happens, right? Anything printed onto the system yet? No? Great. Now, Python is reading this line. When Python reads this line, Python says, okay, I'm going to make a variable, and this variable is going to be called MSG, message, right? I'm going to get some sort of message, and I'm going to call this variable message. I don't know what's going to be stored in here just yet, but let's see what's going to happen, right? What are we going to put into message? Well, anything that's on the right of this equal sign. So it looks at the right of the equal sign. Then it says, okay, we're going to call a function called greeting, and we're going to input something called Mohana, okay? This is a name, Mohana, right? So Python says, okay, cool, greeting. I'm going to call the function greeting, and I have this string with Mohana, right? Mohana, we grab that string, and we go over to the function called greeting. So Python comes back up here, because it says, I know greeting, I've read that before, and I want to go and do whatever greeting is supposed to be doing, right? So let's go to where greeting is. It goes up to greeting. And it has this string. What's the string called? Or what does the string say?
Name.
Not just yet, right? So right now, I'm looking at just this right here. So I am going up to greeting, the function named greeting, and I have something with me. Because this function greeting is asking for a name. What's the name that I'm bringing?
Mohana.
Mohana, right? So I'm bringing in Mohana up to this greeting. We're looking at line 1. Has anything been printed onto the system just yet? Not yet, not yet, okay? So then, it reads whatever greeting has, right? Because it checks to see, do I have a name? Yes, I have a name. Okay, cool. Let's go into the function called greeting. We go in, and it says print, hola, whatever the name is, with an exclamation point. What's our name? Mohana, right? So then we print this, hola, Mohana. Is something printed onto the console now? No? Or yes? Once we read this line right here.
Oh, yes.
Yes. Once we read this line right here, we immediately print something onto the system, right? Because whenever we print something, we just say it out loud immediately, right then and there, okay? And what's inside the print? It's hola, Mohana, okay? So as we're reading this line, we printed something out, this first thing, hola, Mohana. Great. Everyone following so far? Great. Now we finished this function, right? And remember, we talked about the difference between printing and returning. Right now, we printed something. We said something out loud, right? We're not moving any data just yet. Is there a return function here? No, there's no return function. Therefore, once we finish reading greeting, what will greeting return? None. Nothing. It's not going to give anything anywhere. Because we never told the function to give us something, right? And in Python, if a function has no return, it's going to assume, okay, since we're not returning anything, we're literally going to return nothing, right? Not a string that says none, not a 0, not some sort of data type of an integer, float, or string. No. We're returning literally nothing. It does not exist, right? Everyone with me so far? Great. So that means when we call this greeting, we went in here, we printed something out, and we're returning nothing. None. Since we're returning nothing, What gets stored into message?
No.
None. Nothing gets stored into message. Okay, not a string, not an integer, not a float, not a zero, not a string that says none, not an empty string with nothing in it. No, nothing. Right? No string, no nothing. Therefore, message gets none. Message is a variable. It's still a variable, but what does that variable hold? Nothing. It does not hold anything at all. So, we finished reading this line 4. Now we go to line 5. And we're going to print message. What is message? Nothing. It's none. Right? Which is why we get none. None is one of those special words in Python. Just like the special word print, the special word def, right? None is also another one of those special words, which is literally to store nothing. Does that make sense? So does this make sense of why we print out hola Mohana and then none? Any questions on the difference between print and return? No? All right, great. What if we were to do this? Let's return something. And let's return the string, I greeted the person named name. Okay? What happens when we do this?
Oh, then would it will return a message or return I greeted the person named Mohan.
Yeah, Mohana, right? This string gets returned. Therefore, when this got called, this string gets put into message. And then on line 6, when we print message, what's going to show?
I greeted the person.
I greeted the person named Mohana. Right? Let's run that just to see and make sure that it works well. Boom! We get both our things, right? We get this printed hola Mohana because, again, as soon as we see a print, what do? We immediately say something out loud. And we say it out loud here into the console. Hola Mohana. Okay? Then we got this message, and we gave it to the variable called message, and then we printed the message afterwards. Yeah, right there, on line 6. Does that make sense? Great, fantastic. Hello, welcome. Make sure you get a granola bar if you'd like. Okay, so let's continue on. So that's what happens there. What about here? This is a new file. Let's assume what we saw before does not exist anymore. This is a totally new file that we're working with. What's going to happen here?
It's just going to print hola, I don't know how to pronounce it.
Sochi.
Sochi, it's just going to print hola Sochi. Right?
Hola Sochi. Why would that be?
Because there's no print statement. It's only return statement.
Right, there's only a return statement here. So the only thing that's going to happen here is that greeting is not going to print anything yet. It's going to return something, right? It's going to grab the string, hola, the name. It's going to give it back to someone else.
And it's going to give it back to the message.
It gives it back to message.
And then it's going to print hola. Oh, it's going to print 2 times, right? Or no?
Let's count how many times it's printing here. So we read this first line, message is equal to the greeting. It goes to the greeting, it returns something, no printing just yet. We give it to message. Message holds this string, hola Xochitl. We go here, print MSG, so we print once. So we print once something called hola Xochitl. So what should be the answer here? Yeah?
Won't an error occur?
Would an error occur?
Because in base Python, there's no function for greeting.
Right, so in Python, there is no built-in function called greeting. We have to make it ourselves, right? And on line 1, we're calling something called greeting, but so far, Python has not seen something called greeting just yet. right? As it's reading it line by line. So once it sees greeting and it says, hey, I'm going to call a function called greeting, have I met greeting before? Have I learned what greeting does or is just yet? I don't know. Let's check it out. So let's copy this over. Right? Let's run this. Oof. We do get an error. So we were very, very close. I'm kidding. We were very, very close here. Yes. In theory, if we had greeting this before, then your answer would have been correct. Where we only would print it out once, hola Xochitl, and that's it. However, remember, when we are reading a Python file, Python's going to be reading it line by line, up, down, right? And it's very strict. It's very, very strict. And if it hasn't seen greeting just yet, then it's going to say, hey, I haven't found greeting. Therefore, I don't know what you want me to do. Even though later on we're going to say what greeting is, right? Later on line 3, we are telling you what greeting is. But when it first sees the call to some function called greeting, it's not going to know what it is. Right? So immediately, an error will occur. How can we fix this? How can we fix this code?
Maybe the function name, putting it on top, and then putting the message, the variable on the below that.
So this one, this variable, we move it down here, you say?
Yeah.
Yeah? Let's try that out. And let's see what happens. Now that we do this, what's going to get printed out?
Just hola Xochitl.
Hola Xochitl. How many times? Once, twice, 3, 4, 5 times?
Once.
Once. That's right. And the reason for that is because we only called greeting once. And then we only printed the message once. Right? Well, actually, it doesn't matter how many times we call greeting. We can call greeting 1,000,000 times. But greeting will never print anything. It'll only return information. Right? Only when we print something will it be shown here on the console. Let's run that. Hola Xochitl. Just one time. Great. Does that make sense? Yeah? Any questions so far? Yes, no, yes, no? All right. Cool. How are we on time? Oh, man. That was 30 minutes. Oh, boy. We've got a lot to cover today. Today we're going to be covering something called conditional statements. Okay? Conditional statements is basically doing something if and only if something else is true. Okay? And we'll go into all of that right now. We're going to cover something called booleans, if the basics of the if-else, then something called nested ifs, an else if and an if without an else. But we'll go step by step. We won't go too far into it. So the very first thing we're going to cover is something called booleans. Okay? A boolean. Boolean is a data type. We've had data types before. We've had strings, we have ints, and we've had floats. Right? This is a new data type called boolean. Or bool is what it's going to be called in the system. Booleans can only be one of two things. It can only either be true or it can be false. Okay? Let's do a quick boolean. My name is Ismael. True or false? True. My name is Xochitl. True or false?
False.
False. Right? That's all that booleans worry about. Booleans only worry about things that are true or false. Any questions so far on that? Any questions at all? No? Okay, cool. So let's start to see how we can use the power of the Boolean with these things called relational operators. Okay? These relational operators, you may have already seen this sort of stuff in a math class. Okay? This is the less than sign. This is less than or equal to sign. This is the greater than sign. The greater than or equal to sign. Let's look at just this first line first. Okay? Let's look at some booleans and see what it looks like. Okay? Let's start up the prompt. And we're going to do some simple booleans. Okay? With some simple arithmetic. right? Some simple math. Let's get the number 3 and check to see if it is less than 1. Is 3 less than 1? True or false? False. There it is. False. Is 3 less than 4? True. It is true. Is 3 less than 3? False. Is 3 less than or equal to? Less than or equal to 3? True. Right? Awesome. Now we're getting the hang of it. Let's clear this up. Now let's look at the greater than sign. Is 3 greater than 1? Yes. Is 3 greater than 4?
False.
False. Is 3 greater than 3?
False.
False. Is 3 greater than or equal to 3?
Not true.
True. Awesome. Fantastic. Does this make sense so far? How about this? Is 3, the string, greater than or equal to 3, the number?
False.
We get an error. Okay? Remember, Python is very strict in terms of what it can do with certain types. So even though we have this string that looks like a 3, it says 3, but it's in a string. It's not an integer. Okay? Because the same thing I could do with a string, I'll put Ismail. Is Ismail greater than or equal to 3? That doesn't really make sense. How can I, a person, be greater than or equal to the concept of the number of 3? It can't do that, right? Therefore, when we try this, we get an error. Does that make sense so far? Yeah? Let me clear that up. All right, so what have we been getting whenever we do these operations, right? Is 3 greater than 4? That is false. What is this false? What data type is this again? A Boolean. Okay? And Booleans can only be one of two things. What are they? True or false. All right? Awesome. Let me look back here to see what our next thing is. Yes, here we have it here. So same things that we were doing before with expressions, right? We can do it within the Boolean operators. So what I mean by that is this. We can do something like this. 5 plus 5 greater than or equal to 10. Is this true or false? True. Why is that?
It's equal to 10.
It's equal to 10. 5 plus 5 is 10. And then this 10 is going to be compared to the other side, which is 10. And we get true. 5 plus 4. Is that greater than or equal to 10? Is this true or false?
True.
True, right? Why is that? 5 plus 4 is 9. Is 9 less than or equal to 10? That's true, right? So we did that there. Okay, so now we've looked at greater than, less than, greater than or equal to, less than or equal to. Now we're going to do something, check to see if two things are equal to each other, okay? And this is very important for Python. Whenever we check to see if two things are equal to each other, we don't use the greater than or equal to, less than or equal to, we don't use those. If we want to make sure that two things are exactly the same, we use a double equal sign, okay? Is 3 equal to 3? When we check to see if two things are equal to each other, we must use a double equal sign. Alrighty? So when we run this, is this going to be true or false?
True.
True. Is 3 equal to 4? Is this true or false?
False.
False. 3 equal to 2? True or false?
False.
False. Why do we have a double equal sign? The reason for that is because, as we saw before in our Python files, when we have one equal sign, that's only to use to set one thing to another. We're setting something into this variable here. And that's with a single equal sign. when we have the double equal sign, that's when Python learns, okay, I'm not setting something to something else. I'm checking to see if this side of the double equal sign is equal to this side of the double equal sign. Does that make sense? Yeah? Right. Okay. And the last thing that we have is the not equal to sign. Okay. Let me make this up a little bit more. The last thing that we have. So we've had the check to see if two things are equal. Now we can check to see if two things are explicitly not equal to each other. We want to make sure that they're different. So it's 3. The way that we do this is exclamation point equal to. This is the not. Not equal to something. So is 3 not equal to 4? True. Is 3 not equal to 5? True. Is 3 not equal to 2? True. Is 3 not equal to 3?
False.
False. Okay? This is trying to make sure that two things are absolutely not equal to each other. One more. Is 3 plus 4 times 2 not equal to 11? False. Why is that?
Because it's true.
It's true. Well, is it true or is it false?
Oh, if it's 11 equals 11, so
11 equals to 11. How do we know this is 11?
okay, it's 4 times 2 plus 3.
4 times 2 is 8. 8 plus 3 is 11. And because 11 is equal to 11, we're looking to see if two things are not equal to each other. 11 is equal to 11, therefore this is false. Right? Does that make sense? Great. Any questions so far? No? Awesome. All right. So we could do the same thing also by storing things into variables. All right. So let me clear this up. Let's make x equal to 27, and let's make y equal to 13. Okay? Now, is x equal to y?
False.
False. How can I check if x is not equal to y?
The exclamation mark
So I do exclamation mark like this,
and the equal.
and the equal. What's going to happen when I run this?
Oh,
I have to make sure that I put something before and after, right?
yeah, it's x and y.
X,
Yeah,
exclamation point equal,
y.
y. Is this true or false?
True.
That's true. Because 27 is not equal to 13. Therefore, that's true. Right? So we could use this with variables as well. We don't just have to use strictly numbers or strictly floats or integers, right? We could also do something like this. Y is equal to 27.0. X is equal to 27. Is x equal to y?
False.
False? Why would that be?
This one's a float and the other one's an integer.
And one's an integer. Would it be false or would it get into an error?
Oh, maybe an error.
Maybe an error. Maybe not. Let's try it out. Turns out it's true. Okay? So even though we can't compare a string to an integer or a float, Python does know, even though it's very strict, Python knows, okay, one's a float and one's an integer, but they're still both numbers. So I can still compare these two things, right? Therefore, when it does this comparison, it can still do it. Right? But it cannot do it with a string. A string with an integer or a string with a float does not float. Oh. It does not work. It does not work together, okay?
Oh,
Does that make sense so far? We can also do it with Ismail. Is Ismail equal to Ismail? True or false?
true.
That's true. Because this string is exactly like this string. Okay? What about this? Is Ismail equal to Ismail with a space after?
False.
False. Because these two strings are not identical. They have to be identical. And they're not. This has a space after it. This does not. Does that make sense? What about this?
True.
True. What about this? Let's try it out. True. Strings are a little funky sometimes, right? That's why when we work with strings, we try not to use these greater than, less than signs. We try not to, okay? Because there are some rules behind this, right? There are some rules behind it that it's all working in the back end, but we're not going to have to worry about that in our class at all, okay? So for the purposes of this class, we only have to worry about strings when we're looking at equal to or not equal to. Is that okay? Yeah? I just wanted to show it to you so that you know, like, if you're working on your assignment and something like this happens, you accidentally put a greater than or something like that, you might still get an answer, right? But remember, when you're working with strings, try to only work with equal to or not equal to. Is that okay? Yes?
Oh, yeah, but it's true because when the double quotations, when it spaces out, it counts as one, right? Because
it counts as, yeah, it counts as something else. It counts as more, right? It counts as something more. And again, that gets into like more advanced stuff, but you're right, right? This is like starting to get into more of the string. But we won't get into that right now. But yes. Yeah. Proceed. Anyways, does that all make sense so far? Everything that we've covered so far? Greater than, equal to, strictly equal to, not equal to, all that stuff? All right. Here's a quick example. So a quick exercise. In 2023, Karol G and Shakira, they released a song called TQG, okay, Te Quedé Grande. And it currently has 891,354,879 streams. Also, in 2023, Grupo Frontera and Bad Bunny released a single together named 1%. Okay, that means like 100%, right? Or 1%. And which got 867,213,950 streams. Let's compare the streaming numbers to see which was more popular. Okay? So we have this. Think of the other streams. And we have 1% streams with the two numbers. And first we print that, and then we print that. What's going to be the answer?
true and false.
True and then false. Let's try it out. One of the main things about computer science that you should know is that we should always just try stuff out, right? Let's try this out. So, TQG streams is equal to this number. 1% streams is equal to this number. Two really big numbers. Two very popular songs. Do y'all know that song? Do y'all know these songs? No? Dang. I'll put it onto a playlist. I have a classroom playlist thing on Spotify that maybe I'll share with y'all. And both of those songs, great songs. Anyways, then we have this. We want to print out whether these streams is TQG streams greater than 1% streams. It's true. Why is that true?
Because the kid, this one's bigger than the other.
This one is bigger than that one. Great. Simple as that. Okay? These are variables. Same thing with it before. So instead of greater than, or less than, or sorry, greater than, we can check less than. Is this true or false? False. Right? And that's what we get here, true and false. Any questions? No? Cool. All right. How much time do we have left? Oh, we have an all right amount of time. We also have something called Boolean operators. Okay? First, we check to see if something is equal to something else, if something is greater than something else. We try to evaluate whether some things were true or not. Right? True or false, true or false, true or false. We also have this thing called Boolean operators. So we can check to see if one thing is true or false, or something else is true or false, or and one thing and another thing are true or false. And then if something is not true or false. This all seems kind of difficult so far, but bear with me here. With this table, like this slide is going to be very important for y'all in the future in terms of how to better understand what this all means. Basically, we have something on the left side and something on the right side, and trying to see if both of those things are true or false. So let's say we have something called A and something called B. And first off, we're going to say that A is true and B is also true. Okay? That they hold those Boolean values. One is true and another is true. If we check to see if A or B is true, we just have to check to see if one or the other is true. If either one of those two is true, then it evaluates to true. This whole thing, A over B, is true. That means that if A is true and B is false, as long as one of these things is true, this whole thing turns into true, right? Because A is true, even though B is false, A or B turns into true. Does that make sense so far? Same thing vice versa. If A were to be false and B were to be true, that means that we still get A or B. One of them has to be true. It's true. Okay? Now, if A is false and B is false, then A or B, it checks to see, are one of you true? Neither are. Therefore, it all turns into false. Okay? Does that make sense in terms of how to use or? We have a similar thing with and, right? A and B have to be true for A and B to be true. And that sounds weird when I say it out loud. But let's look at it at the example. A is true. B is true. Are A and B true? Yes, that's true. A is true. B is false. Are A and B true? No, that's false. A is false. B is true. Are A and B true? No, it's false. A is false. B is false. Are A and B true? No, it's false. Okay. Only if two things on either side of the and, if both of them are true, then it evaluates to true. Does that make sense? Okay. And then lastly, we have something called not. It just flips things together. A is true. What's not A? The opposite of true? False. A is false. What's not A? The opposite of false is true. Okay. Let's look at some examples. Here we go. Okay. So, let's exit this. Let's clear that up. And let's work with this here. All right. So, let's work with some numbers. X is equal to 10. Y is equal to 20. Okay. And these Boolean things that we've been getting, true or false, they can also be stored into variables. Okay. They can also be stored into variables. So we could say answer is equal to X less than Y. Y. Let's print out the answer. What happens when this happens? What's going to get printed onto the console? True. True. Okay? So we can work with this with variables as well. Okay. Yeah. Okay. All right. So now, what we can also do is check to see with ands and ors and all these things and the nots. Okay. So first, let's check to see is x less than 10 and y equal to 20. What's going to happen here? All this is going to get stored into this answer. Okay. So first, let's read what's going on here. Is x less than 10? That's false. So this becomes false. I wish I had a, let's do it over here. Whoops. Sorry. I like using a chalkboard. So we have x less than 10 and y, what is it? Equal to 20. Right? This evaluates to false. And this is y equal to 20. Sorry. Put this in here. This turns into true. But we're looking at an and here. False and true. What's this going to turn into? False. The reason why this is false, why is this false?
Because both conditions have to be true.
Both conditions have to be true on either side of the and, right? What if, what if I were to change this to this?
True.
Why would it be true?
Because only one of them has to be true.
Only one of them has to be true. In this case, this is true, right? So as long as one of them is good with the or, here we see that this is true, therefore the whole thing is true. Okay? Does that make sense? Yes, no, yes, no? So when we were to run this, we get false, because we're still using the and, right? But when we use or, this is true. We could have done it like this too. What's this going to evaluate to now?
True.
True. Okay. Great. Now, let's work with the not, right? So let's work with this one, or, right? So this, as it is, what is this, true or false?
True.
True. Right. And then this is still true, right? That's what we have up here on the board. X is less than 10, or y is equal to 20, right? One is false, one is true. Since we're using or, it's all true. What if we did this? Not. Not. What does not do again?
It flips the true to false.
It flips it true to false or false to true. So y is equal to 20, that's true. With this not,
False.
this now becomes false. And because this is false, or this is false, what happens here?
Turns into false.
This all turns into false. Do we understand why that is? Why is that? Someone from this side of the room.
Well, neither option is true, so it has to be false.
Neither option is true, therefore it has to be false. Let's run it. False. What about this?
True.
True. And that is because x is not less than 10, because x is 10, 10 is equal to 10, therefore this is false. But then with the not, it turns the false into true. Does that make sense?
Yeah.
Awesome. Great. Oh, yeah. Let's do this. So we're back to this, right? We run this. This is true because only one has to be right. And on this case, y is equal to 20, right? If y is equal to 20, one of them is true, therefore the answer is true. We all know that so far, right? That makes sense? But remember, Python is very picky. What if this were to have happened? Instead of doing y equals 20, I say the answer is equal to x less than 10 or y is equal to 20.
Give an error.
It'll give you an error. Okay? And the reason for that is called syntax error. Invalid syntax. Maybe you meant this, right? Maybe you meant double equal. There's other stuff too, but don't worry about that other stuff. We're worried about this double equal. When we do this, when Python is reading it, remember Python is very strict. So even though you and I, all of us here, know that what we meant is that y is equal to 20, is equal to 20. That's what we meant. That's not what we wrote. We wrote something else. We wrote we're setting y equal to 20, even though we're in the middle of setting something else over here. And Python's going to be like, whoa, hey, we're not supposed to be doing that, right? I'm going to throw an error at you, and I'm going to stop reading, okay? Because you didn't write it right. Does that make sense? Why there was an error here? Yes? Yes, no? Awesome. All right. So, oh gosh, this is already giving you away the answer, but anyways, same thing as we had before. X is equal to 3, y is equal to 7. Not x is less than y. We know that x actually is less than y. 3 is less than 7. but we had the not, therefore it becomes false. Same thing here. X is equal to 10. We know that that's not true. And y is not equal to 20. This is true, but we have this true and this false. Therefore, the whole thing becomes false, right? This whole thing becomes false, but we're putting a not on this entire thing. Therefore, the whole thing that was false now becomes true, okay? Because of the power of these parentheses. Remember, those, the PEMDAS thing of before, of parentheses, exponents, all that stuff, that still applies here, right? We had these parentheses. Therefore, everything inside these parentheses, we're going to not whatever all this was. All this was false, but we're going to make it true, right? Same thing here. It's a little funky. So we work our way from inside and work our way out. So in the innermost parentheses, x is equal to y. Is x equal to y? No, that's false. But then we're going to not that. So this false becomes true, right? So that's in here. But that true, we're going to not that. And that becomes false. Okay? This looks a little weird and funky, and why would we ever do that, right? But this is just for the matter of showing you the power of the not and with the parentheses. Okay? Does that make sense so far? Yeah? Awesome. Let's look at this. We have a couple of holidays. We have someone that wants to see if they've gone to all these holidays. One is Carnaval. Carnaval is a Brazilian festival before a Christian holiday. And we're going to set that to true. I went to Carnaval. Okay? There's also Inti Raymi. Inti Raymi, I did not go to Inti Raymi. That's an Incan New Year for the people of the Inca that lived in Peru, Ecuador, and Argentina. Okay? And then we also have Dia de Muertos. Dia de Muertos, I did go to Dia de Muertos. And that's a Mexican holiday honoring the dead. Okay? So I'm trying to check to see, have I attended these events? El Carnaval, or Inti Raymi, or Dia de Muertos. And I want to print out this variable, has attended events. What is the answer here?
True.
True, why is that?
Because Carnival is true, and also the other Dia de Muertos is true.
Right?
And it's just or, so as long as one is true, they're all true.
Right. As long as one of them was true, then it's all true. Okay? Because we're using the or. Carnaval, or Inti Raymi, or Dia de Muertos. We print it. Has this person attended any of these events? They have. At least one. Right? So that's why it's true. Okay? That make sense?
Yeah.
Awesome. Excuse me. And now, just like we had the whole parentheses, exponents, the PEMDAS thing of the order of operations, there's also an operator precedence in Boolean operators. The main thing that takes the highest priority is the not. The not is the most powerful. Okay? Not above all things. So when you're reading some stuff, not is the first thing that you have to look at and try to implement that first. Then you have the and. Okay? And is the second most thing. So as soon as you see an and, if you don't see any nots, and is the next thing you're supposed to go and do. Then lastly, or. Or is the lowest priority. Because it's a lot easier to get true with ors. Harder to do with ands. And then nots will just flip everything on its head. Okay? Let's do a couple of these just to see what it looks like. What is the value of the expression below? We have this num. Num is 17. Okay? Actually, let me write this down here so we could do it one by one. So we have not. Can people read it out for me? Not num.
Equals
17.
or num.
Or num.
Greater than or equal to 17.
Greater than or equal to 17.
And then num.
And num.
The would divide.
This is the integer divide. Yes?
2
equals 8. Okay? So, remember, we have to think about the order of the operations. Okay? What's the first thing? What's the top of the order of operations that we have to do? The not. So first, we check to see this. Not. What is not referring to?
Num.
Num is equal to 17. So, first thing we do, sorry if y'all can't see over here, num is equal to 17. Is num equal to 17? Yes, that's true. But with this not, now this whole thing becomes false, right? Then, so we have this false. And now we have or num is greater than or equal to 17 and num is floor divided by 2 equal to 8. What's the next thing on the order of operations that we have to focus on? The and, right? So now we look at this and we have to look at the right and the left. Okay, and is the very next thing we have to do. So, left or right doesn't matter. Which one you want to do first?
Left.
Left. Is num greater than or equal to 17?
Yes.
That's true. Right there. And now let's go to the right. Num double divide 2. Remember, this is integer division. So after we do the dividing, we just remove whatever was in the decimal place. So 17 divided by 2 is 8 point something, right? We don't have to worry about what's after the point. So it's 8. So is 8 equal to 8?
True.
That's true. All this is true. And now we're looking at the and. But remember, the and was the most important. Because of that, true and true? True. And now we're looking at this. The or. That's the last thing we're supposed to be looking at. False. Or. True? That's true. Because only one of them had to be true. And it was here on the right. Does that make sense?
Yeah.
Of how we got to that? Let's just write that down and see how it works. Make sure that I'm not giving you all some false information. Whoop-de-doo, doo-doo-doo-doo. Okay. So we clear that up. Num is equal to 17. Python. Sorry about that. I had to write Python first, remember? Python to open up the prompt. Okay. Num is equal to 17. Then we have this. Not num is equal to 17 or num is greater than or equal to 17 and num floor divided by 2 is equal to 8? True. True. Okay, does that make sense? Of the order of operations, the first thing you have to do is the not. Then the very next thing you have to do is the and. Then the very next thing you have to do is the or. That sort of thing. Okay? Great. We have 20 minutes left. And now we're going to the if else. Awesome. We're good on time. Let me see. Okay. We can also, here, let's do this really quickly. Let's do this for the next 5 minutes. If you go to your laptop, we have this lesson on, in the lessons tab. In this lessons tab, if you go to lecture 4, you'll find this, okay? What we can do is take a couple of minutes to try and create a function to decide if a number is even or odd, okay? Even or odd. And this is going to be using our booleans, right? We're trying to see if something is true or is false. Is it even or is it odd? Right? A binary thing. Right? I'll give you all just a couple of minutes to think about that. You can write it on your paper as well. You write it on the paper, use your laptop, however you'd like. Okay? But we're going to write a function, and we're going to call it is, even, or odd. And it takes one input called num. Okay? I'll put a quick timer. I'm going to give you all just a quick hint with this. Something that was really important that something that we learned in some past lecture is the following. We use something called the modulus, right? This little percent sign. And what this little percent sign is going to do is it's going to give you the remainder of something, okay? Using all the math stuff that we did before. So, just as a quick reminder of what modulus will do, let's say we have the number 3, and we're dividing 12, right? How many times does 3 go into 12? 4 times. 4 times 12, we get 0. Therefore, the remainder is 0, so our modulus is 0. Okay? That's how modulus goes. Same thing as like this. What if we had 3 goes into 13? How many times does 3 go into 13? 4. 12. We get 1 left. We're starting to put the decimal, but we all, as soon as if we're doing modulus, we're looking at the remainder. And what's the remainder? 1. Okay? That's what modulus does. So modulus is going to be very important in creating this right here. I'll give you all just another minute to think about what we want to do to find out if something is even or odd. Oh my gosh, I just realized we can't even do this without going over the next step. I'm so sorry. This is going to be a good transition into the next step, okay? So we're trying to check if something is even or is odd, right? So we want to give back to the user whether a certain number is even, we'll return the string called even, or we'll return the string called odd, right? This is totally my bad. This goes into this big idea. The idea of if and else, okay? If else. One thing to look at with this really quick is some of these like special words, these keywords that Python we've used so far, like def to define something, printing, right? Because that's a function already. The and, the or, the not, all these words. If and else are also keywords in Python, right? And these if and else things, these things are called conditionals. So basically, it's only going to run the code within it if something is true, okay? So here we see if speed is less than or equal to 40, we're going to say thank you. Else, otherwise, we're going to say slow down, okay? This is like some speedometer, right? You may have seen these out in the road, right? It checks to see what you're driving, it compares it to the speed limit, and if you're under the speed limit, it might say thank you, or if you're over the speed limit, it'll say to slow down, or it'll start like blinking lights at you, right? So, the if and else is very important, because if and else, let me move over here, if and else is going to help us to print or to only execute certain lines of code if something were to be true. Only if something is true. Okay? So let's do something really quickly here. X is equal to 10. Y is equal to 20. We can use this if, right? If something were to be true, so let's see, if X is less than Y, then we have this colon, just like we have with the functions, remember? With the function, we had to use a colon to tell it, okay, we're going to start our function. We're doing the same thing here. With the colon, okay, we're going to start off, if this is true, we want to do something, right? And we're going to tell it what it is. And in order to do that, you also have to have those spaces. The spaces with it. Remember how Python is very specific about spaces? It wants these spaces, this indent here. So, if X is less than Y, let's just print out X is less than Y. Okay? Let's run this. What's going to happen when I run this? When I run this, Python's going to read the first line, x is 10. Python's going to read the second line, y is 20. It reads the third line, nothing's there, it skips it. Then it reads the fourth line. If x is less than y, I'll go inside this conditional statement. Okay? I'll go inside and read whatever's inside. Right? And if x is less than y, we will print out x is less than y. So what's going to happen when I run this? What's going to happen?
X is less than 1.
X is less than y, it'll print it out, x is less than y. Okay? Because we went inside there. But, what if we did this? 20. X is 20, y is 20. Is x less than y? Is x less than y? False, right? Because this is false, we should not go in here and print that out. So when we run this, what's going to happen? Nothing. Nothing is printed out. Okay? It'll read it, but it won't print it, right? We can also do something called else. Else is basically going to say, check to see this if thing first. Check to see if that's true. If that's not true, then we'll do this. Otherwise, let's do this. Else, let's do something else. So here we could do print x is not less than y. Okay? We can do that. So, what's going to happen when I run it now?
X is not less than
X is not less than y. Python reads x is 20, Python reads y is 20. Python checks to see if x is less than y. Python sees x is not less than y. This is false. Therefore, anything that's in here, we're going to ignore it. We're not going to read it at all. Then it checks to see, it reads line 6, and it says else. Okay, we check something else, but if that's false, read this anyways. No matter what, just read this instead. Okay? X is less than y. We run it, and we see x is not less than y. Okay? Let's put it back to x is 10. What's going to happen here?
X is less than y.
X is less than y. Will it print this?
No.
Why not?
Because it's the if statement is true, so it doesn't count the else unless it's false.
That's exactly right. Because we run this, we do see that x is actually less than y. Python says, okay, this is true. Therefore, I'm going to go inside here. I'm going to print out, I'm going to do whatever it says to do in there. And then Python's going to read this line 6 and it's going to say else. So like, well, if that other stuff was false, do this instead. But the other thing that we did, that was true, right? That Boolean expression was true. Therefore, we can ignore this now. We ignore the else. Does that make sense? Yeah? So, let's look at this. What's going to happen here? We have a code example with if and else. We have created a function called speed message, right? And we're going to check in with the speed. Speed here is going to be an integer, right? If the speed is less than or equal to 40, it'll say thank you. Well, it'll store thank you into message. Otherwise, else, it'll store slow down into message. Then we're going to return the message. What's going to happen when we run this?
Only 45 will be on the else, but the rest will be on the if statement.
All right, so what will happen? What will get printed when this runs?
Thank you.
Thank you. What will get printed when this runs?
Slow down.
Slow down. What will get printed when this runs?
Thank you.
Thank you. Okay. Does everyone understand why that is? Yes? Let's copy it over. Let's run it. So we have thank you, slow down, and thank you. Okay? And that's because, again, Python reads the file, it reads line 1. It says we have a function, all right, and then it reads all from line 1 to line 6. This is all the function stuff. Great. Then it reads line 8. And it says we're going to print something. All right, what are we going to print? We're going to print whatever speed message 38 returns. Okay? We go into speed message with 38. 38 goes in here. Is speed less than or equal to 40?
Sure it is.
That's true, right? So therefore we go inside here and we make the message equal to thank you. Then we look at this else. Are we going to read into this else?
No.
No, because this was true. Therefore, we return the message. Whatever it was, in this case, is thank you with this one. Same with this, 45. 45 goes in here. Is 45 less than or equal to 40? No. It goes, so therefore, we go into the else. Slow down. So message is now slow down. And this gets printed out slow down. Same with 40. Is 40 less than or equal to 40?
Yes.
True. Therefore, we go inside here, make the message into thank you, and return the message. And then we print out that message down here. Ready? Cool. Whew. All right, so back into this function thing that we were talking about, is even or odd. So we had to make a function called is even or odd, is even or odd, right? And we had to take one input called none, right there, none. And we're going to start the function. There. Now, we're going to check to see if the number that we have is even or is not even. How do we check if a number is even or not?
Modulus.
With modulus, right? But in terms of math in general, how do we know if a number is even or not? Like, let's look at this number right here. Or sorry, what am I doing? I'll just use this. Is 2 even?
Yes.
Is 3 even?
No.
Is 4 even?
Yeah.
Is 5 even?
No.
Why?
The remainder.
Because the remainder. Because the 2 and 4 are divisible by 2. 3 and 5 are not divisible by 2. Therefore, we can use the modulus. Right? So, we can check to see our result is equal to num modulus 2. Right? So modulus 2 is going to give us the remainder. So we know it's even if the remainder is what number?
0.
0. So if result is equal to 0, then we can return even. Okay? As we had here. We say return even. Return a string that says even. Okay? Oh, whoops. Instead of that, that's a little, here, listener. Instead of result, let's call this even or odd. Or actually, let's call this remainder, right? If the remainder is 0, then our result is equal to even. Else, right? It doesn't matter what other number it is, as long as it's not 0, we know it's not divisible by 2. Therefore, we make that equal to odd. Then we return the result. Okay? So now, anytime we call is, even, or odd, any number, say any number out there in the world. 20. Run that. Oof, what happened?
Forgot to print it.
We forgot to print. We returned the value, the result, but we didn't print it. Print that. We run it. That's even. Another number.
55.
55. Even or odd? Odd. Cool. Great. So now we can check to see if the number is even or odd. We have 2 minutes left. Oh boy. Any questions on this condition of if or else? No? So what does this mystery program do? This will be the last thing we look at today. We have a function called mystery, and we're going to print out whatever mystery gives us when we give it the number -42. It'll print out 42. 42. Why is that? Let's go step by step. We have the defined mystery. It has some sort of function. Great. Python reads all this, and Python says, oh, it's awesome. Anytime I see mystery, I'm going to run all this stuff. Then we go here. We're going to print out whatever mystery gives us. Inside mystery, we're going to put -42. We go to mystery. With n is now -42. If n is less than 0. Is negative 42 less than 0? Yes. So we go in here, and then we return n times negative 1. What's negative 42 times negative 1? 42. Right? It flips the negative to positive, or positive to negative, and then we get here, and we print out 42. Great. What if we were to input the number 42 instead of negative 42?
Just print out 42.
It'll just print out 42. So we run this. This is 42. If we put 42, it's still 42. And why is that? It gets the number 42. It goes up here. It checks it. Is 42 less than 0? True or false?
False.
False. Therefore, we go to the else. Then we see return n. We just return whatever it was. So what is this mystery function actually doing?
Absolute value.
It's the absolute value, right? No matter what it is, if it's a positive, it remains the same. But if it's negative, it'll make it a positive. Always. All right, cool. That make sense?
Yeah.
All right. Man. We're 1 minute over. I'm really sorry about that, y'all. I hope you all have a wonderful moment, wonderful evening. Next lecture, we'll be covering nested ifs. Nested ifs. Basically putting if statements inside of other if statements. Okay? But we'll cover that next week. All right? Thanks so much, everybody. Make sure to work on PA1 and submit that on by Monday, or use your slip days. And then we have lab 2. All right?
Thank you.
Awesome. Of course. Make sure to take a granola bar. If you'd like some more, please do. Hello, yes.
Yesterday I forgot to submit